Hi. So here we have if 3x plus twice mod y plus y is 7 and x plus mod x plus 3y is 1, then x plus 2y is what? Okay, so what you'll have to do here, since we have mod of x and mod of y, you'll have to make cases for both x and y. For x, you'll have to make two cases. One is when x is positive and one is when x is negative. And similarly for y positive and y negative, you'll have to make two cases. So we'll have a total of 4 cases. What are the 4 cases? Case 1 is when x is greater than equal to 0 and y is also greater than equal to 0. Then case 2 will be when x is greater than equal to 0 but y is less than 0. Case 3 will be when x is less than 0 and y is greater than equal to 0. And case 4 will be when both x and y are less than 0. Okay. Now, if you look at this particular equation, x plus mod x plus 3y is 1. Now, we have x plus mod x. As long as x is positive, x plus mod x is fine, no issues. But if x is negative, what happens is, we know mod of x will be equal to x if x is greater than equal to 0. But mod of x will be equal to minus x if x is less than 0. Right? We know this property for mod. So here, if x is less than 0, what happens is, in this equation, we get x plus mod x will be substituted with minus x. And then we have plus 3y is equal to 1. Okay. So x minus x becomes 0. 3y is equal to 1. Hence y comes out to be 1 by 3. So if x is negative, the only possible value of y is 1 by 3. Hence what happens is, we will have to reject this case. We get a positive value of y, right? But we don't get a negative value of y. Hence this case is rejected. And to verify whether this case is even possible or not, let's see. Y is positive, fine. Now we got y equals to 1 by 3 from this equation. Let's substitute y equals to 1 by 3 and figure out the value of x from this equation. Okay. So if you put, we have 3x plus twice of y. Now since y is positive, twice mod of y will be twice of y. So this will be 2y plus y, 3y. So 3 times of y, which is 1 by 3, is equal to 7. Okay. So what we have is 3 by 3 is 1. 7 minus 1 is 6. So 3x is 6. That gives us x is equal to 2. The value of x comes out to be positive. But what we assumed was that x must be negative. So again, the solution that we get does not fit with the conditions that we assume. So even this case is rejected. Right? So these two cases can be straight away rejected. One, because since if x is negative, y comes out to be positive. It does not satisfy the conditions here. And x is also positive, which does not satisfy this condition here. So both these cases are rejected. Now let us look at the first case when both x and y are positive. So if both x and y are positive, the first equation that we get would be 3x plus twice of y. Mod of y will be y when y is positive. So we'll have 3x plus 3y is 7 from the first equation. And x plus mod x will be same as x. So we'll have 2x plus 3y is 1. 2x plus 3y is 1. This is the second equation. Right? Now if you solve these two, you subtract the second from the first. So 3x minus 2x is x. 3y minus 3y is 0. 7 minus 1 is 6. X comes out to be 6. Okay. Now if x is 6, what we get is 2 into 6 is 12. 12 goes on the left hand side. 1 minus 12 is minus 11. So 3y is minus 11. Y comes out to be minus 11 by 3. Now think about it. Is this possible? No. Because we assumed both x and y to be positive here. Right? So even this is rejected. Fine. Now coming to the final case here. Case 2. X is greater than equal to 0 but y is negative. So if y is negative, mod of y will be minus y. So we'll have 3x. The first equation will be 3x minus twice of y. Mod of y will be minus y. So minus 2y plus y is minus y is equal to 7. And the second equation will be x is positive. So x plus x will have 2x plus 3y is equal to 1. Okay. So now to solve this, what we'll do is we'll multiply this equation with 3 and add both of them, right? So 3 into 3 is 9, 9 plus 2 is 11x, 3 into minus 3 is minus 3y, plus 3y cancels out, 3 into 7 is 21, 21 plus 1 is 22. So we have x is equal to 2 from here. And if x is equal to 2, substituting x equals to 2 over here, 2 into 2 is 4. So we have 3y is equal to 1 minus 4, which is minus 3. Hence y comes out to be minus 1. Okay. Now if you look at the values of x and y, x is positive, y is negative, and that is what we assumed. So the solution that we get fits well with our assumption. Solution here did not fit well with our assumption, and the solution here did not fit well with our assumption. So all these cases were rejected. The only acceptable case is case 2, and from there we get x is 2 and y is minus 1. So finally what we need to calculate is x plus 2y, right? X is equal to 2 and y is equal to minus 1. So twice of minus 1 is minus 2. So this comes out to be 0. Hence the answer to this question is that x plus 2y is equal to option C, 0 here. Thank you.